This is a golden kelp forest, a mesmerizing and magical ecosystem that is home to all kinds of marine life. And the term forest really encapsulates the essence of this place, because when you dive underneath the canopy of this aquatic jungle, you uncover a whole new world, a bustling three-dimensional habitat that acts as the cradle of the ocean and offers a safe haven that shelters the young of many different species. But unfortunately, many of these places have disappeared in the last 50 years due to what we believe to have been a mix of pressures, such as bottom trawling for fishing and nutrient runoff from polluted rivers and drainage. However, with cleaner rivers and tighter regulations on fishing, we believe there's now an opportunity to try and bring back some of these forests, which is of course why we've been hard at work developing a project that can do this at scale.
This project has made a ton of progress in the past year, so I'm really excited to share with you all the different updates. And to do so properly, we're going to have to go underwater so that I can show you the project area, everything that is living down there, all the amazing little creatures, and of course, how our young kelp forest is developing.
But before we get into that, let's first take a look at how these forests work, to understand them a bit better. Here along the Portuguese coastline, we have 6 native species of forest-forming macroalgae, but in our area, the forests are mostly comprised of 2 species. First, we have Saccharisa polychaetes, which has an interesting life strategy. Its life cycle is annual, meaning it does all its growing in a few months in spring, and then releases its spores at the end of summer. And at this point, the kelp dies and releases from the rock in the first autumn storms. This accelerated life cycle allows it to be opportunistic and quickly colonize bare rock when conditions are suitable. Then we have Laminaria ochrolueca, which is a perennial species that can live for a few years. This means that you can see it year-round, and it's a bit more predictable to work with, which will become relevant later in this story. The way you tell them apart, by the way, is at the base. Laminaria looks like it has roots, while Saccharisa has a wide foot. Well, in case you wander randomly into a kelp forest, you should be able to tell them apart. Now, if you're a member or a longtime viewer, you'll recall that we worked with Sea Forester on a trial of the spore bag technique, where we collected the sori of the annual Saccharisa kelp and attached it to rocks at a new location to try and create a new forest there. This technique ultimately failed to produce any meaningful results, and, well, this is actually really valuable data. You see, often organizations don't share their failed tests, but they should, of course, because it can inform others. So right now, Tiago, our biologist managing this project, is working on aggregating data from several partners and publishing a paper on this technique under our Conservation Evidence Partnership with the University of Cambridge. And since then, we've shifted to using a new method called green gravel. It's essentially growing kelp on rocks and then dumping them in the ocean. But there's a bit more to it. This technique was pioneered by the Institute of Marine Research in Norway and has been successfully tested in quite a few places by now. In Portugal, our partners at Sea Forester and Mare Polytechnic of Leiria have tested this out with Laminaria ochrolueca, the perennial species, and they got some great initial results. When looking at the bigger picture of bringing back these kelp forests, stage 1, or testing, is now complete. We know that this idea works, which means that now we can tackle stage 2, which is a succession of larger experiments to see if we can achieve the desired results in a larger area. And finally, if everything works out, the third stage will be to go into mass production and mass restoration. To get the ball rolling on stage 2, we built 5 modules, which have the capacity to produce 80 trays of green gravel, with about 300 stones in each one. The production cycle is around 3 to 4 months, and this year, after a bit of tweaking, we finally started our production. The first step in this process was to collect the spores from a wild kelp forest. We focused on Laminaria ochrolueca, the perennial species, because with Saccharisa, the patches would disappear each year and reappear somewhere nearby or potentially somewhere further away, and this would make it really hard and also really expensive to monitor. The crew for the spore collection was Jan from Sea Forester, Álvaro from IPL, and Tiago.
So we are here in Peniche and we are going to dive on a healthy kelp forest, and the goal is to collect some reproductive material that we can use to start the cultivation cycles at the kelp nursery.
The The collection process was fairly simple. Identify the source of the kelp, where the spores are stored, and cut that part of the blade, and then put it in a bag and take it out. The amount we collected does not harm the existing forest, but it will go a long way in our lab.
We just finished the dive now to collect some soil material here in Peniche, and we got quite a good harvest actually. So we have two full mesh bags full of material now. And you can see those sorry patches where now we will take this back to the lab. We will prepare the blades, and then they will be kept overnight, and tomorrow we can do the spore release.
The spores are then extracted, and over time they grow into gametophytes, which we're able to keep in the lab in this phyto chamber, with the right conditions for the gametophytes to live, but not to start evolving into kelp. And this means that we're able to keep them there for a really long time, which is quite useful, because we don't want to be going to a wild kelp forest each time we want to start a new production cycle.
So once we have the gametophytes from the phyto chamber, the next step to start a production cycle is to spray them onto the gravel. And we have the gravel, so these pebbles, on each of these trays here, and we spray them onto the rock. And then the kelp attaches, and then all we have to do is provide them with the right conditions for them to grow. And so this means having moving water, which is what you can see here. So there's this circulating system of water, and then also having the right temperature, so about 14-15 degrees is what we're using, and then also the right light conditions. So here the light is controlled by a computer, which has a night and day cycle, and where the intensity changes over the growing cycle to promote growth and to simulate what they would find out in the ocean.
The most important feature that we're looking for in a new area is for there to be plenty of reef structure so that the kelp can attach to it. And these lovely rocky mazes are ideal for this. But I have to point out, this place is by no means devoid of life. Here you'll find all kinds of fish species, some going about their life relatively carefree, and others are more cautious and have evolved to blend into their environment and disappear from sight. Then there are these colorful sponges attached to the rock, these rather chunky sea hares munching on the algae, and of course, a variety of beautiful nudibranch. They're these tiny, soft-bodied marine gastropod mollusks that try to look very, very toxic to predators with all their bright colors and flashy effects. But at least to me, and to my eyes, they only end up looking absolutely fabulous. My point is that there is already a living ecosystem down here. But the return of the kelp and the shelter and food it provides could help improve things significantly for all of these species, but crucially, also for the ones that are not present in this reef. You see, we dove on this project site the day after freediving the healthy kelp forest, and the difference was striking. In the kelp forest, there were so many baby fish and baby invertebrates that it was hard to swim there without going through a little cloud of them, while at our project sites, I never saw a single young fish. And I think that tells you a fair bit about how these places help support marine life populations. We ended up choosing two rocky reefs as our project sites. One here near Cascais and another one closer to the nursery. And after about 3 months of growing, the young kelp was ready to deploy. At this stage, once you get them out of the nursery, it is really important to keep them cool and moist, and also to get the deployment done relatively fast. For the first deployments near the nursery, we used the old family car to get the stones to the harbor. But later on, when we were deploying near Cascais, it was a bit of a long trip for them. So we rented a refrigerated van to help keep the kelp cool on their 2-hour road trip down to the harbor in Cascais.
Yeah, so now we're just loading all the gravel onto the boat so that we can take it out to the site and deploy it. So we arrived here in Berlingues, and now the next step is to set up the perimeter where we will be deploying the gravel. And so Alvaro is going in and getting these boys and creating like a square, which is where we will be releasing and dropping the pebbles.
We did this across all our deployments, adding a new square to each area and marking it with GPS points. Each square is 35 by 35 meters, or around 1225 square meters. And while we don't cover the entire area in stones, it is really useful having this limited range, because it makes it much easier to monitor the deployments and make sure that the results are clear. And once the buoys are in place, it's finally time to deploy the kelp.
After all the work building the nursery and caring for the kelp, it's very cool to be here and to finally see it drop into the water.
The deployments went really well across the different locations, and I think that this shot that Tiago got of the parachuting kelp gravel is really exciting to see, because it looks and feels like a proper scalable solution. A bit like carpet bombing the seafloor, but in this case with something really nice and positive that will hopefully grow into a forest. And at the bottom, we could see that the stones were well spread over each of the areas. So all we needed to do now was to wait for the results. Of course, while continuing the production of the next few batches. Now, before we check on the results, I think it's important to explain the funding structure for this project. We've budgeted 88,551 euros for the project until the end of 2023, with 22,250 euros being used for the building of the modules in 2022 and 66,301 euros for the 3 production cycles planned for 2023. The funding for this came from these lovely businesses right here that supported this project directly, and also from our amazing Mossy Earth members, which are a group of people that help fund our projects with a monthly contribution. And if you'd like to support our work, you can do so by signing up at mossy.earth. By becoming a member, you'll be funding dozens of different projects that help bring back wilderness across a diversity of ecosystems. We plant trees in Iceland, flood forests in the Danube, restore rivers in Scotland so that salmon can thrive, among many other such projects that have all sorts of different angles on how to restore nature. And there's also quite a few really exciting ones in the pipeline, but more on that soon. We report all of this to our members through regular updates, videos like this one, our transparency dashboard, field reports, project podcasts, and much, much more. So if that sounds like something that you would like to support, then please consider heading over to mossy.earth to learn more. Now, let's go look at this baby kelp forest. Our deployments are staggered, as not every module started producing at the same time. And this means that when it was time for the second deployment in Cascais, we could finally check on the development of the first batch. I think their reactions tell you everything you need to know about how much this means to the whole team. And 1 month later, I was back in the water with Tiago to do some monitoring and to film this for you. And the kelp was looking even better. Look at all our lovely kelp. It was so amazing to see. So many stones had developed, and the newer batches were coming along nicely as well.
And we found some really nice results. So some of them had kelp like this big, like 7 centimeters or something. So that's a really, really good sign. And it's very exciting to see, because this is also the place where we've been trying to get some kelp to grow for a long time, since we did the trial with the spore vac technique. So these are very promising results. We need to keep monitoring. But it's just very, very exciting to see.
So what is the future for these experimental plots? Well, this kelp faces an uphill battle, I'm not going to lie to you. Our hypothesis is that the conditions here are better now than they were in the past, but we don't necessarily have proof that they are, because we have no baseline data from 50 years ago. We also picked a really tough summer to start these deployments, as sea temperatures have hit a record high this year. And then there are also natural pressures, such as herbivory. Some of our kelps had big chunks bitten off, and the current pressure could be too much for a forest to easily develop. Our strategy is to continue our deployments to reinforce each site and to try to reach a tipping point where we have a self-sustaining forest. For now, there are still many stages to go and many questions to be answered. Will the young kelp survive the summer? Will it attach to the reef? And when spring comes, will it start reproducing? Together with our amazing partners at Maria Pealeria and Sea Forster, we're on this journey for the long run. And it seems that we now have a working tool that we can continue improving to try to achieve this ultimate goal of bringing back these amazing golden kelp forests.
I think we are right there, so close to the mass restoration of these ecosystems that, yeah, it's just a really exciting moment. So a huge thank you to everyone who's contributed, who's been a member to get us to this point and to get this project to the stage that it's in. And yeah, as usual, if you'd like to support this kind of work, then please consider heading over to mossy.earth and becoming a member. I can't say thank you enough. Until next time. Cheers!
¡Vamos!